Hey folks, welcome to Advent of Code in F Sharp, day 4. I was not planning on doing an episode this early today because I had to arrive at the office, but I think we're having our first and only snow day of the year, so plans changed and we have some time freed up. So let's take a look at today's puzzle. Scratch cards. The gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As a circle of snow island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much more warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh hello, the elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure, I just operate the gondola lift. That does sound like something we'd have though. This is Island after all. I bet the gardener would know. He's on a different island though, the small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Yes. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards as a gift, but I cannot figure out what I've won. Okay, so the elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has two lists of numbers separated by a vertical bar, a list of winning numbers, and then a list of numbers you have. We get everything in the table, which is our input. Cool. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles point value of that card. Okay, that sounds very doable. So in the example, card 1 has 5 winning numbers, 1, 2, 3, 4, 5, and 8 numbers on the card we have, yes. Of the numbers you have, 4 of them are winning numbers. 1, 2, 4, 8. Yeah, so that's 8 points. Makes sense. Take a seat in the large pile of colorful cards. How many are they worth in total? So we just need to count points for every card we get. That sounds simple. That's interesting because this year has been a bit on the harder ramp-up side, at least for me. We have 196. That's a weird number. 196 cards in our own input. So let's dump that in. Our cards are significantly larger than the example, but that should not be a problem. Okay, how will we tackle this? I think the good old parse and do stuff approach works here as well. So I'm just gonna parse every line into a data structure that lists the winning numbers and our own numbers. Can you have duplicates in there? Probably not. I'm thinking, should we use lists or sets? Making sure like what is in where is easier if you have sets. Like the union between two sets is an easy operation if we work with sets. So I'm gonna start working with sets and keep in the back of my mind that if we do have double entries, that won't work as well. So maybe let's do a quick scan of the input. Do we have the double entries? Who knows? We could verify this by parsing, but yeah, let's maybe do that. So I'm going to introduce a type. Card has an ID, but we won't be using it for part 1. And then it has winning numbers, which is a set of numbers. Is this how you specify the set type in F Sharp? No. So this is probably how you specify the set type. So that's the winning numbers, and let's just for now do a list. a list of integers to grab our parsed numbers, and then we'll just do a quick scan to see if we have any doubles in there, duplicate numbers. Okay, let's write a parser. We could use regexes. This is good, or we could use string splitting. I still have not brushed up on my regex magics, so let's do a string split approach. This is my example line, which we can play around with. And let's write a parser for this. Yeah, let's do a string split approach. So card number, or I'm just gonna split on the card ID first. So that's line split on this. There we go. And then let's parse the real card number, which is card number split on space, and take the second part, that should be the card ID, and we can parse that into a number. Don't really need it right now, but hey, why not? Okay, so now let's parse the numbers. Winning numbers are before this pipe. So let's split on pipe. Some name collisions, so let's fix that here. There we go. This should parse into two lists. Yes, why are there this many spaces in there? Interesting. That's not a problem. Okay, so now we have two lists of numbers, and we can parse both into lists of integers. So we can split on. Can you remove empty entries? What's the string split options thing in .NET? So you give a char array and options. So let's give it an array of characters. That's okay, because we're splitting on space. And let's do a, is there no overload with a string and string split options? Let's remove empty entries. Yeah, and let's map over that to an integer parse. So we have our numbers, and let's do the same for our numbers, or the card numbers, and that is numbers using the same parsing logic. Quick scan, that looks correct. And let's use lists instead of arrays, because why not? Or no, and we're going to parse this into a card type, and that's a set, so this is okay. So let's return the card with an ID, card ID, with winning set of the winning numbers, and our numbers is just the card numbers. Mapped to a list. So I think this is our parser. Let's try it out. Yeah, and now let's quickly check for duplicates. So this is the entire parsing logic. Grab that out, put that in a function. My formatter went a bit crazy here. Line is a string. Let's help the compiler. So it stops complaining. There's a bit of warnings about possibly failing destructurings, but that's okay. We know that will never happen. Famous last words. Okay, good enough for F# in Advent of Code scenarios. So I'm gonna continue on. We don't need this. We've just seen this work. I'm comfortable. Also famous last words. What I'm gonna do before solving the problem is taking a look at the input, see if we have duplicate numbers in there. So for that, I'm gonna do a parse of the entire file. So every line we're gonna parse into a card. That does not work. That's interesting. That's interesting. The parse is already failing. There's 2 spaces in there. Is that okay? Well, where is all this extra space stuff coming from? I think that might already be the problem, right? Sometimes we have 2 spaces. So I'm gonna pretend I didn't see anything. And I'm gonna do the same remove empty entries trick here. And let's try again. Yeah, this is parsing. So let's now do a quick check for the duplicate numbers. And then we can rework to sets all the way if we're comfortable. I'm going to do that by checking the count of making it a set versus the, or we can just say numbers, give me the distinct, give me all different numbers, give me the length of that, and that should be the length of the original thing, and give me all the cards where this is not true. That should give us problems, and there are none. So yeah, every number is unique. Let's do a quick rework so our numbers are also in a set instead of a list. Minor change. There we go. Let's parse this again. There we go. And now solving the actual problem should be easy. We need to count the point totals for a card, and for that we need to know how many winning numbers are in our numbers. So that sounds like a simple set operation. So let's let's map every card to a point total. So for every parsed card, let's map it to its points, and a point function that takes a card and returns a point total. Points for a card are the number of winning numbers in my numbers. So that's a set.union of card winning numbers and card numbers. And then we count how many we have. Let's hits. And then we double. What's the mathematical formula for doubling? So if you have 1 winning number, it's 1 point, 2 winning numbers, 2, 4, 8. That's a power of something, right? 1, 2, 4, 8, 16. Is it 2 squared to the power 3? Are we getting there? We are getting there. So 2 numbers should give us this, so it's hits minus 1. If we have 1 hit, it's 0. 2 to the power 0 should be 1. Yeah, that's working out. So calculating points is 2 to the power of hits minus 1, and that should give us our point total. And let's verify this with the example. Why is this not working? Expecting a string. Oh, my compiler is a bit cold, I guess. So we have way too big a number. That's not correct. What's going wrong? Parsed. What is parsed? 13, 18, 13, 18, what even is this? Oh, sorry, that's ID 6. ID 1, 17, 41, 48. That's step 1, yeah. And numbers is 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm doing a union. Oh, union is putting two sets together. That's not what we want. We want to intersect, right? And what's the bigger set? The numbers that should come first, probably. That will work. Hopefully a bit better. 822100. 822100. Yeah, that's correct. So if we do this on our input now, oh no, what do we need to do? Sum them up. So this should give us part 1. I'm gonna wrap everything into a solve function. And we have not written any tests, but let's keep this one thing in a test for posterity. That should be 13, right? Yeah, that's 13. And for us, for our input, it is a bigger number. Let's see if this is correct. Hey, 1 gold star. Good job, us. So, part 2. Let's see if I have enough time to knock this one out. I'm just going to copy over the script so we don't have to work with what we had before. We can just go through it with the grove borstel, as they say in Belgium. We can make broad sweeps. Okay, what's part 2 all about? Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Ooh, interesting. You win copies of the cards below the winning cards equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win copy each of cards 11, 12, 13, 14, 15. Amazing. Okay, so 5 matching numbers, 5 cards. I don't get what cards. It's like ID is 10, we have 5 matches, so we take the next 5 cards. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, you would win a copy of the same cards in the original card. Okay, this is meta, but okay, yeah. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. What a twist. Okay. So still sounds doable. So the example goes differently. So we're still looping through all cards and scoring them, right? That does not change. Okay, card 1 has 4 matching numbers, so we win a copy of the 4 next cards, which is 2, 3, 4, and 5. Yes. Our original card has 2 matching numbers, and we win 1 copy of cards 3 and 4, but we already had card 2. We had a copy, so we scored 3 and 4 2 more times. This gives us 1, 2, 3, 4 copies of card 3, yeah. Okay, so we win a lot of copies and we just duplicate cards that are further up in the row. So this gives us with a lot of cards, but what is our point total? So once all the originals and copies have been processed, you end up with this many instances of whatever cards, yeah? In total, this example pile of scratch card causes you to have this many scratch cards. How many total scratch cards do you end up with? Oh, we just need to count the number of cloned, copied cards we have at the end of the run. Okay, that is doable. Okay, that sounds like a fun twist. I'm just gonna copy the example to be 100% sure. Nothing changed. So the parsing can stay, but instead of scoring points, we have to add copies of cards depending on how many points a card is worth. So this point thing we can still use, but instead of just using that as a point value, that's the number of cards we need to copy. We don't need to literally copy cards, we just need to keep a count of, for every card ID, how many cards are in there, right? And then we treat every card once, and we take a look at how many copies we have. Yeah, I think that'll work. We can just loop over it once. We don't have to do any crazy stuff. So let's make our data structure a bit more rich. We have a list of cards, which is right here. We're parsing into a list of cards. And now let's keep also a running total of, for this card, we have this many copies. So I'm gonna introduce some state, which keeps track of my cards, but that's just a lookup table. Let's just use a map that maps card IDs to cards. So that's a lookup table for all our cards. And then let's keep another map that does the same thing, but maps counts. So it maps a card ID to the number of copies we have for a card. Let's make that a bit more explicit. Let's give a... Oh no, yeah, maybe for this type signature. So a card ID is just an alias for an integer, but then we can make that very explicit that this maps card IDs to something. And this is the number of copies. So yeah, let's work with something like this. Go through the entire list of cards. Is it sorted? It is sorted, so yeah, that'll be easy. And let's start copying and copying and copying until we finish going through the list. So this is parsing into our list of cards. Now let's build some initial state, which gives us a parsed map of list, but that has to be tuples with key value pairs. So let's map our card to the card ID and the card, and let's wrap that in a tuple. And now we have a lookup table. So that's our cards lookup. And we also need our number of copies. And that is mapping every card ID we have to the number 1, because we have every card once. So that is parsed list map card ID and 1, and we put that into a lookup table. And that's our lookup table. Why is there this many blue squigglies? Okay. That's our initial state. Okay, so now we can start copying cards. And how do we do this? Pseudocode, or my algorithm, in my head at least, is going over every card we have in the lookup. Yeah, so this is actually a bit of a useless thing, but we'll go over every card in order. We'll count the points that this card is worth. This gives us which cards we need to copy over. We update the number of copies, and then we go to the next card. So this sounds very much like a fold again. You can do almost everything. Every loop you would write in C#, whatever, you can do with a fold in F#. And I think it's actually a nice fit for today's problem. So let's write a fold. So let's loop over our cards. Write a folder function, which means we'll just score and copy. And the initial state for our folding function is this thing we just built. So we need a little helper function. Which takes a state, the current state, it takes the card we're seeing right now, and it returns a new version of the state. In our example, we are going to score points. Didn't we have a points function? Oh, it's a point function. So let's rename that to points. So give me the points for this card. And then we know which cards to copy. So let's then create the card IDs we need. IDs to copy equals start from the current card ID and work until you have card ID plus the points. Card ID plus 1 actually. So say we are at card 10 and we have 4 points, then we need 11, 12, 13, 14. 11. Yeah, I think we need to subtract 1 here. I think so, but let's verify that. So say we have 10, then we take 11, 12, 13, 14. I have to see this running. My brain has not waken up yet. Are we gonna do that now? Oh, come on, it's such a little problem. Let's do that now. So say we have 4 points, then we need this plus 1, yes. It's actually this, we don't need to subtract. Yeah, it makes sense, so 14. These are the IDs we need to copy. And then we can update the state. And for every ID in there, we need to bump the count by 1. So that's... yeah, we could use another fold here. Let's give the type system a hint that we're working with state, so we know what we can expect, number of copies. So IDs to copy. For every ID we need to copy. Yes, so for every ID we need to copy, we do something with the state. Let's just return the state for now and provide initial state. This will work. And then we return state with, or let's just return new counts. Let's keep it all. Let's have every fold update the state. That'll work. And now we just need to do this. So given an ID and a state, we need to bump the count for that state. And I'm going to call it exactly that. So let's extract another mini function. And how do we bump the count for an ID? That's just state with. Let's help the type system again. How do you insert a record in a map? Change, what does change do? Returns a new map with the value stored under key changed according to F. That's basically what we need, right? So we give it a key, which is ID, and we say bump by 1. And I saw something of option in there. Okay, let's deal with the option case, sure. We expect there to be a value every time. So I'm just gonna destructure on sum, if that works. Let's return sum count plus 1. So this blows up if our map does not contain the card ID, but I think it always does. So this should potentially work. Let's give it a try. Let's score and copy, let's solve. So if we run solve on the example, we get a hard crash, of course. The match cases were incomplete. Interesting. So probably this is crashing. Let's take a look at our stack trace. Yes, it's changed, it's crashing. So we have card IDs. Interesting. We have card IDs that are not in our lookup table. So our count logic is wrong, or map lookup is wrong. Interesting. Let's print out what we have here. Some good old debug-driven development. So let's print out our ID and our state whenever we bump a count. And let's see what's going wrong here. Sorry, what's going wrong here? Okay, there it is. So something is going wrong. And we are at bumping card count for card 7 in state where there's only 6 cards. That's not supposed to happen. And we already duplicated some cards here. So where is this 7 coming from? It's an ID to copy, so we're scoring points for cards. Let's print out these points again. Always need to look up where my percent sign is. So it's this card has these points. Okay, so we're bumping a lot of 3, 2 points for card 1. Is 8. Is that correct? Oh yeah. I'm doing the multiplication thing. Our points, the points function is wrong. So we are still doing 1 times 2 times 4 times 8. That's not what we have to do. We just have to count the hits. So it was not the initial points function we need. That's silly. Okay, if this is our only bug, that's okay. I'm gonna rip out our print statements to keep our logs a bit more manageable. And let's rerun this for the example. So we have our state with some cards in there, and we have a number of copies. 1, 2, 3, 4, 4, 1. 1, 2, 4, 8, 14, 1. That's totally incorrect. How did we end up here? Yeah, that's not correct. Oh yeah. I see what's going on. Whenever we're looping over a card, we take it as 1, but actually we have a lot of copies maybe already. So when we are doing when we are looping over our cards, right here where we're bumping count, we are like seeing this card as 1 instance of the card, but in our counts we might have more than 1. So this 1 is not really correct. We should or when we're bumping counts, given an ID, so that's coming from here, the IDs to copy. Those are the IDs to copy, but we might have to copy them more than once because we have this card this original card, so the card we're scoring, might be in there already 4 times, and that also has to propagate. Yeah, so let's look up the copies we have for this card. And that we have to also propagate. So if we have 3 copies of a card and it copies over cards, whatever, 13, we don't have to create 1 more copy of card 13, we have to create 3 times. So this 1 can just be replaced by the number of copies, is my educated guess, and that should work. 1, 2, 4, 8, 14, 1. 1, 2, 4, 8, 14, 1. That should sum to a 30. Let's see here. So these are the intermediate results, and then we just take folded dot number of copies and we sum by the counts, which is the second thing. I'm trying to do too much here, so that's a map. Let's make it a list again, and then we can do our list.sum by, and it's the second thing in the tuple, so that should work. We should see 30 here, we see 30 here, and if we run it on our input, we see a much bigger number, which might be our solution, who knows. And again, 0 tests. I keep saying I'm gonna do better next day, and I never do. Yeah, we have a number. Let's verify quickly. And we have our 2 stars. So not the cleanest of takes, but we got there. And actually we got there in 37 minutes. I am very happy with today, all things considered. So let's do a quick recap. For part 1, we just had to treat every line individually and see like how many of the winning numbers were in our card. And the only interesting thing we did was using sets. So we can do a very easy set intersection to see how many overlaps there are. That's a neat trick you can use in a lot of these Advent of Code puzzles. But part 1 was pretty basic. Then part 2 got interesting because we started copying cards instead of scoring points. And our good old fold function yet again saved the day. And we just had to loop over every card, see how many copies we generated for cards in the further down the line. And there was a bit of a tricky thing where I forgot to propagate the number of counts, but we got there in the end. There's still a lot of squigglies here, but that's how I like to solve my Advent of Code puzzles. This will not be okay for production code, but for a quick puzzle solve, it's more than enough. And that's how we got there today. Still no regexes, and I still don't feel bad about it. Whatever gets the job done, right? Cool puzzle. Yeah, this was a cool puzzle. I am very interested on your take. I see a lot of people doing Advent of Code and F# today. So if you took a different approach, or if you ended up with less than 100 lines of code, please, I would like to see. Please shout out in the comments below. And otherwise, I will see you tomorrow for more Advent of Code in F#. Bye-bye.